Alright, so yeah, this is meant to be like the hardest question in the world, and you don't need any prerequisite knowledge. Though there is some knowledge that would help a little bit to kind of get things started a bit faster. Um, so you know how we had that joke fundamental theorem of tournament towns? This might also be another joke fundamental theorem of tournament towns, but so tournament towns managed to come up with these amazing coin weighing problems, okay? And I guess the fundamental theorem of tournament towns for like just any weighing problems, like whenever you take a weighing, right? Like the results split the number of possibilities into different outcomes. Does that make sense? So like if you weigh a bunch of coins with a bunch of coins, they could tie, yeah, or they could one be heavier than the other, or the other one's heavier than the other one, right? So there's always three outcomes for each weighing, okay? And sort of just knowing sort of fundamentally how that works um, can lead to certain ideas, okay? So maybe that's the first step for this problem. So how can you think of as like um, how can you think of it in terms of having three different outcomes for each weighing, and then what what kind of sort of what kind of bounds does that give you for the maximum possible n? You know?
It's a question, right? It says force us into the way of at least one point. That just means relative to all other points, right? Because there's no way to actually find the mass.
Yeah. So that's a good that's also related to what I'm asking. So what does it mean in terms of so in this framework? What does it mean to know the weight of exactly one coin, right? So like if you have one, two, and three, um, if you know the weight of this coin is one, right? It could also still be one, three, two, right? Okay. Yeah, so that's definitely part of it. Um, but it's also possible to know like every coin as well, yeah. Like so, so in some sense, you don't you have more than just one possibility at the end, okay? And I want you to think about what are the possibilities and how do the weighings actually sort of split the possibilities into groups, okay? So that's sort of the first question. It's a little bit open ended, but I'll kind of tell you exactly what I mean. I never like just telling you exactly what the answer is. Okay, so I'll give you some stimulus, you figure it out, and then I kind of tell you, okay? So it's not three groups of coins, right? Because yeah, like yeah, because the coins you put yeah, it's hard to explain, but like yeah, like what are the things that get split into the groups by the weighing, yeah? So it's not quite the coins, you understand? It's something else.
The point where one turns into N.
Okay, I feel like maybe we'll give you some time to form your thoughts, but I only give you 2 minutes. Okay. Does everyone understand what the problem's asking? Okay. Yeah.
Wait, so determining which side is heavier means that if it means that if the sides are equal, that means you know because well neither of them are heavier, so
Yeah.
so then you also know if it's a tie.
Yeah. So there's three possible outcomes. So I guess use this idea like it's pretty much like a very general idea. Okay, it applies to all sort of weighing questions. Um, of course, you always have the chance to discover the idea yourself. But In the interest of time, I'll reveal the idea in like another 1 to 2 minutes. Yeah, so we're converting the conditions of the problem into something. Yeah.
So like when you weigh like say two of the sides with like three different group bases like on which side the balance scale is on. So you basically express that as like a ternary digit, I guess, if you catch that gist. So I will postulate the largest n is 3 to the power of x. Okay.
Okay. Yeah, I think you kind of caught on to the idea. Okay, but maybe not expressed it very well. Okay, so let me try to demonstrate this idea in the case n is 5, okay? So let's say I have like 1, 2, so I have 5 coins, right? So I'll represent them as like markings on a circle. Something 1, 2, 3, 4, 5. Yeah? Okay. And what I want at the very end is, for example, I know the weight of the top coin, yeah? And that weight could be like 2, yeah? Okay, I figure out the coin weighs 2. Okay. Okay, but I still don't necessarily know what all the other coins weigh, yeah? It could be like 3, 4, 5, and 1, or it could go the other way. It could be 3, 4, 5, and 1, yeah? Does that make sense?
Possibilities.
That's 2 possibilities, okay? Now, I could also happen to reduce it to 1 possibility, right? And then I know not just 2, but I actually know where all the other coins are weighed, yeah? That makes sense? So I guess what I'm trying to say is I want to define a possibility as a possible solution for the weights of these 5 markings, yeah? So like a possible solution could be 5 here, 4, 3, 2, 1, yeah?
Yeah.
Okay. So if you think about it, how many possible solutions are there?
2 I think.
Yeah, so basically you can, for this case, there's 5 numbers you could put at the top, right? But there's only 2 other choices to make. It's either clockwise or anti-clockwise. So in this case, there's 10 possibilities. Does that make sense? Okay. So what happens if there's 10 possibilities? So for example, I can take a weighing, like I can weigh this coin against these 2 coins, right? That makes sense? Okay. And suppose I get a tie, right? yeah?
Yeah.
And I get a tie. What possibilities are consistent with the tie there, right?
1, 2, 3.
Yeah, it could be 1, 2, and a 3, right?
1, 3, 4. 2, 3, 5. Wait, no, they don't have to be consecutive. Apart from, like,
Yeah, they have to be consecutive, yeah? So it could also be 1, 2, 3 the other way, right? That makes sense?
Wait, can it be the first way around?
2, 3.
Yeah. Oh wait, what? Oops, sorry. It's
You meant the other way
1,
around.
2, and 3. Yeah, these two add up to that one. Yeah,
Yeah.
that makes sense.
Yeah.
Okay, these two add up to that one. Okay, but is there any other two consecutive numbers that add up to the next one? So if you have like
2, 3, 5.
5 and 1, that doesn't add up to 2, right? 4 and 1.
4, 5, 1.
They aren't connected.
Yeah, so it's like 4, 5, and then 1.
4.
I don't think there is.
No.
No.
There's like no other combos, yeah?
Yeah.
It has to be odd, that's the point.
Okay. Unless, yeah, it goes from 1 to 5, it's a bit different. But yeah,
I would see.
okay. So this is the only possibility, yeah?
Yeah.
Where it's a tie.
Yeah.
So what that does is it reduces it just to one possibility. So it's 3, 2, 1, 5, 4. Yeah? That's the only possibility. Does that make sense? And so whenever it reduces to one possibility, then you know all the coins, not just one of the coins. Yeah? You're actually dripping water. Okay, but then there's other results, right? It could be the 2 coins weigh heavier, yeah? It could be these 2 is heavier, yeah? The 2 is heavier. That could be another outcome, right? Does that make sense? So what possibilities correspond to 2 being heavier?
Quite a lot.
Pretty much like all of them, right? Which ones aren't? So maybe we'll go lighter.
So other than 1, 2,
2 is lighter. When is 2 coins lighter than the one that's next to it?
5, 1, 2.
5, 1, 2.
So, yeah.
So like this is
Clockwise.
right. So this is like 5. This is 1, 2. Yeah.
Yeah.
Is that the only case?
Probably not.
Can't start with 4 and you can't go the other way around. So it's like that number has to be 5 because otherwise, like, otherwise it's not
Okay. So then there's the only possibility. Yeah. So that's a 5.
This is a depressing example.
1, 2, 3, 4. Yeah. Okay, and then therefore all the other possibilities must correspond to the last conclusion. Yeah.
Yes.
That makes sense. So what's really happening? So what's really happening is you got 10 possibilities at the start, right? You take a measurement which divides it into 3 groups, and then we got one possibility, and 8 possibilities. Does that make sense? Okay. And then what you can conclude is that weighing could not possibly solve the problem by itself, right? Because in this case there's 8 and that can't determine a coin. So to determine a coin, there needs to be 2 possibilities or 1 possibilities.
And the 2 possibilities have to be like the one.
Yeah.
Is anti-clockwise, one is clockwise.
Exactly, and the 2 possibilities have to be the rotations of each other. Okay. Okay, so what does that mean? Well, it means that ideally, so why is it not possible to do everything in 2 moves, right? Because if you had, say, like 20 possibilities, right? Then in 2 moves, in 1 move, you can do at best like 7, 7, 6, right? And the 6 you can do 2, 2, 2, but the 7 you can't do 2, 2, 2. There has to be at least a 3, right? So when you get down to these possibilities, you can't solve the problem. Does that make sense? Okay, so immediately we know that if there's 10 or more coins, we can't do it in two weighings. Does that make sense? Because 10 coins give you 20 possibilities.
Oh,
Yeah? Does that make sense?
yeah.
Okay, there's actually also, there's lots of, this gives you a lot of clues as well, okay? But I want you to discover some of them as you're doing it. Okay, so I'm going to give you a bit of time. So the biggest you can do, if you have n equals 9, right? That's 18 possibilities. So in principle, 18 could be 666 and then 222.
Yeah.
So,
The question is this possible?
so in principle, that could be done. So the first exercise, I'm going to give you some maybe at least 15 minutes for this one, is can you do 9 coins in 2 weighings? Okay? Can you do 9 coins in 2 weighings? So can you find, and I'll give you a bit of a hint. I'll give you a bit of a hint if you're stuck, when some time has passed. So k equals 2, k equals 2, n equals 9. Okay, that's what we're doing now.
When you ask, can you do it in like 2 ways?
Yeah.
Are you asking like, is there a way we can do it, or is it like,
Yeah.
can you do it every way?
Of course you can't do it in every way. Like there's some weighings that are just useless. Yeah. Oh, why?
No.
Okay, if we had more time, we'd be able to. We'd actually go through the smaller cases too, but
I have
we start with 9. Okay.
how do you do 3? That's
Yeah. So actually, if you do 3 coins, 3 coins, 3 coins, you need 2 weighings. You know? So 3 coins, you can only do 2 versus 1 or 1 versus 1.
9.
So 3 coins, you need 2. You know?
The thing about trying to
So then 9 is the next power of 3. You know?
It's actually so hard to get it that there's like more than like one time.
Yeah, how do you?
Because of the consecutives, it often means that what you flip it around and it doesn't work. You add like a number to all of them and it doesn't work. Anyway,
I'll write numbers down to make it easier to imagine.
I mean, the cases where it's like there is no sort of wraparound where you go from the largest number to the smallest number, like you can just turn them into algebraic equations. But if it does have a wraparound, then it's going to be a bit more complicated.
is a bad idea.
Are you sure it's a bad idea?
No.
Exactly.
Uh,
Self-doubt.
how many is a tie?
Tie, what do you mean? Like they're equal?
Does everyone know what we're trying to do? Maybe even just try to find like a good first move. Okay. So actually, what do we know about the first move? We know that it has to. Remember what we said? We have to go from 18 to 6 to 6. Okay. So you have to choose coins that have to have the possibility of tying. Does that make sense? So there's going to be 6 cases where the results are tie, 6 cases where one's heavier, and 6 cases where the one side's lighter. Okay, so the 2 coins you pick, they have to have the possibility of tying, right? So for example, you can't just pick this versus this. Does that make sense? Because they can't ever tie. They're all different. Okay, so that would never work as a first weighing or a second weighing. Yeah. So you have to actually use multiple coins versus.
I don't think that's possible. I think the maximum number of ties is 2. I can't prove it.
See, you can't do like 9 versus 4, 5. So that's gonna tie, right? But there's only like 2 ways for that to tie. Yeah, it could be 4 and 5 switched and with the 9 there, but there's no other numbers that like. Right, it's 7's to 2 and 3, right? See, 7 can't tie with 2 and 3. 8 can't tie with 3 and 4. 6 can't tie with 1 and 2. Only 9 can tie with 5 and 4. So what that's gonna do, if you do that, it's gonna go turn 18 to 2, and then it's not gonna be right. Yeah. Okay. So actually, if you're trying to get some ties to happen, there's actually not many ways you can start your weighing.
There's
The
always
reason why
one.
Andy says there's like only like a maximum of 2 possibilities for a tie, I'm assuming it's because one of them is like there is no sort of wrap over that like
Magical
now we have like
pendulum.
the numbers.
How is it?
3, 2.
The numbers are like 1, 2, 3, 4, 5, 6,
There's a
7,
lidless
9,
water bottle out there.
But like
Oh, that's probably mine.
I thought that was yours because you're drinking from one with a lid on it.
This is stupid.
I never expected the lid to be there.
Quite peculiar.
oh, hold up a minute. Okay. If you can no, okay, never mind. I feel like the best possibilities are if you have like an even number of numbers against an even number of numbers.
Oh, why is that?
Right. Oh wait, no. Maybe
Proof
not.
by a guess.
Oh wait, no. Okay. The vibe is that like if you find like a possibility for when they tie, and then if you can lower all of the numbers by 1, and like they still and like none of the numbers like are like 1, so that you can actually lower all of the numbers by 1 without making an even tie, then you just have another possibility. So you have like more possibilities. Whereas, like, if you do the same thing, but like, one of the numbers is 9 and one of the numbers is 1, well then you'll just get a different set of numbers because,
Yeah.
but yeah, the thing is that, like, with an odd set, like, you can't really, like, subtract 1 from everything and, like, make it, still work, so you're much more limited.
Yeah, so you can't use all the coins as well. It's a special case of Patrick's odd. So if you have the total is like odd, it can't be split up into 2 equal groups.
Oh, yeah, you can't.
Wait, question.
Yes.
Does the question say that you can only choose 3 consecutive coins?
No.
I can choose, like, for example, 1, 4,
Yeah.
1, 4, 7.
Yeah,
Of course you
exactly.
can.
Exactly. You can choose whatever coins you want.
This is why it's SA7. This is like SA7. And not
It's see, having more choices is kind of this is what's disguising the right choice, yeah, with other
there's
choices.
a right choice.
Yeah.
No, now we have to find the right choice. This is.
I mean,
Is that it? Please come back here. I just want this problem to end.
no, Andy.
Your game cannot be that deep.
It's like,
It's like this is a nightmare waiting to unfold.
My child reward center is trying to reward me as much as possible.
It's a 3 groups, like 6 possibilities, right? If you have another, like, outcome, like, another way, I guess.
Yeah.
We always split it into, like, everything into 2, 2, 2.
Yeah.
So that's like, so you even know that it's like. What do we mean?
No,
by
2 is fine.
What do we mean by 666 and 222? Like, I saw like the table, like the tree. Like, I don't know what it actually means.
Oh, it would have been good to ask at that point. So like, when there's 9 coins, there's 18 possible arrangements of the 9 coins.
Yeah.
And for you to be able to determine 1 coin exactly, you have to reduce it to only 2 possible arrangements. So we're doing 18 goes to 666 and then 6 goes to 222. You see why it's into 3 groups? Because every weighing can be heavier on the right, heavier on the left, or tied.
Like, what do you mean by like 666? Like,
6 possibilities of correct orientation. Like if this answer is tie, then how many possibilities do we have out of all?
Yeah, like which possibilities are consistent with the result of tying? I actually gave very explicit examples with N equals 5. Do you remember those? Were you paying attention?
yeah.
Yes, I think that's it.
Locked up.
Imagine if he worked at like a problem-solving sweatshop, where like he has to provide the answer every 15 minutes, or be docked pay.
He's one of the guys in like the
Yeah,
World
but
War
it's
II
really
code
good
breakers.
pay.
He's one of the
It's
World War II
sweatshop pay.
code breakers who like spends
Sweatshop pay is like
10 hours every day
Huh?
to like
Sweatshop pay is
try
mine.
combinations.
Yeah.
It's Chinese sweatshop pay. It's even worse than normal.
Chinese sweatshop pay's not that bad. At least it's not a third world country.
I think it's changed a lot since when the word sweatshop was first mentioned. The conditions have improved a lot.
If you look at the pay is bad. But if you look at how much you can buy with your pay,
The
it's
reason
not
why
that
they
bad.
call it a sweatshop
Alright,
is
guys.
because it's constant fire hazard.
So are you ready to spoil the first move? Actually, it might not spoil it because I'm just giving you a move that gives you 666 possibilities, right?
Oh.
Yeah.
Okay, so imagine. So one of the things you can look at, you can see if these.
But not.
See these two numbers here, right? They add up to 11. You see,
Yeah.
and these add up to 11, and these add up to 11, and these add up to 11.
Solution.
Okay, so you could potentially weigh. So you weigh these 4 coins, yeah, against these 4 coins. Okay. Now can you see? Can you see how many ways there are of tying?
Yeah.
So you gotta. So obviously we're in a tied configuration, yeah.
Yeah.
So we could.
If we start from 1.
Yeah. And this particular weighing doesn't care about if it's anti-clockwise or clockwise. So if this is a solution, then going the other way is a solution, right?
Yeah.
So I can sort of label this weighing by like the number that goes here, for example. Yeah. So I can call this just 1. Yeah. You understand? And that gives me 2 possibilities. Yeah. Does that make sense? Okay, what is the other possibilities?
2. It's flipped around. The ones
not
on
a
the tie.
tie.
The ones.
I'm looking for the ties.
5. The ones on the other
Yeah,
side.
5. Yeah, so if this
Nine.
happen, if the top thing happened to be 5, right,
Oh,
then it would look like this. So you're weighing these 4 against these 4, yeah. And notice this adds up to 10. 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 So it's 20 versus 20. That's a tie, right? So 1, 5. 5 also is a tie, yeah. What else is a tie?
9.
9. Okay, so what happens here is
They all add up to 9.
yeah. Those all add up to 9.
they add up to 9, and then it's 9 versus 18 versus 18, right? So those are all ties, yeah. So these are all possibilities that would give you a tie, because any of them could have been at the top, right?
Yeah.
It could be 1 or 5 or 9 at the top, and they would produce the same results, right? Okay. So then, what about the cases where the 5 minus 1 bit is bigger than the 4 numbers? Which
2.
The 5 minus.
so like this bit is bigger than the other bit. What?
I think 2 works.
Are you sure? 2.
3 definitely works.
All right, let's have a look at. Are you sure?
Wait, other way around?
Yeah, you might have it the other way around.
Yeah.
Okay, so if we look at 2, okay, if 2 was at the top, okay, it would be like this, okay? This versus this. So which one's heavier? This is a tie.
Yeah.
So one set of results. So the 2 falls under the I guess let's call it lighter, yeah. And then heavier is the other one, yeah. So if you put 3, you see 3 is going to be lighter because it's literally next to all the light things.
So literally all of the lightest ones on one side, all the heaviest ones on the other side.
Okay, that's going to be lighter than this, yeah.
It's like a 5 watch.
4 also works. 4 is actually lighter.
Okay, 4 is same idea, right?
Yeah, 4 is.
So when you center them around the light things,
Yeah.
it's going to be light. So this is lighter than this, yeah? You see? This is 5, 10, 16. This is 17 just with a 9 and 8, yeah? So 2, 3, 4, yeah? And then what we're going to get...
What is that? 6, 7, and 8 are all heavier.
Yeah, so if we do 6, 7, and 8, so 6 gives you this is
Heavier.
heavier, yeah?
Yes.
So this is 6. And then
7 bunches all the heavy ones.
7's like the opposite of 3.
It literally is the opposite.
Like, exactly.
alright, so 7 obviously is going to be heavier than these ones, yeah?
Yeah.
Okay, and then 8 is the last one. So 8 got a bit smaller because of the 1, right? But but it's still got 9, 7, and 6, which is just already way heavier than 5, 4, 3, 2. Yeah? Because 5, 4 is like the 9. 2, 3 is lower than 6 even. Yeah? Okay, so then 6, 7, 8. So then can you see this breaks it up into 6 cases, because each of these is actually 2 cases. Yeah?
Yeah.
Does that make sense?
Yeah.
Okay. Okay, so what we need to do now is we need to, in each of the 3 cases, provide a move that divides it into 2, 2, 2, right? It needs to solve the problem with one more move.
And that's equivalent to saying like it tells you which of the 3 numbers it starts from.
Yeah. Maybe not necessarily.
Okay, I think I have one for the tie. From the 1 go 2, 3, and 5. If it's 1, if it's a tie, then the answer is 2, 3, 5, so it's a tie. If it's a 5, then it's 6, 7.
Oh, sorry. What was your claim? So we're saying we're tied.
Bunch 2, 3,
Let's say
and
it's
5.
tied, yeah?
Yeah.
And
Bunch
you're
2, 3 with 5.
2, 3 with 5.
Yes, from perspective of 1.
From the perspective of 1. Also,
Assume 1 is the top number, then do this.
so that's the one that you excluded in the first weighing.
Yeah.
And then you're weighing 2, 3 versus 5.
Yes. If it's a tie, it's 1. If it's greater than, then it would be 7 and 6 with 9. So the 2 would be greater than that little one. And if it was 9, it would be 1 and 2 with 4. So.
Wait, confusing. Hold on, let's see. So if you weigh these two together, right?
Yeah.
Is 5 the only thing that adds up to those two things?
I see.
5, 6, and 7, 4, and 3.
Oh wait.
Where's 4, 3?
Direction. No, it doesn't work with the opposite direction.
Yeah.
It's not symmetrical.
It needs to be symmetrical.
Well, lesson learned.
Okay, so let's go back to the tires in a bit. Let's work out the lighter, heavier. Okay, so what does it mean to work it out? Well, so let's say that's lighter, yeah? So lighter is 2, 3, 4. And that means we have 2 possibilities of this form. So 2 goes here, and then it's like 3, 4, 1, 9, that's like 8, 7, 6, 5, yeah? So that's like 2 possibilities, yeah? It's either this or the other direction, okay?
Yeah.
Another possibility is it's 3, and it's 4, 5, 6, 7, 8, 9, and then it's like 1, 2. So that's 2 possibilities, either this or the other direction, yeah? Okay. And then the last possibilities is 4, 5, 6, 8, 9, 1. Right now. 9, 1, 2, 3. Yeah, it's either this or the other direction. Yeah. That makes sense?
Yeah.
Okay, so we need a move that separates those separates those 6 possibilities into 2, 2, 2, yeah?
The middle and the bottom.
Oh, yeah.
A lot of ways.
Yeah.
So from the 2, do 9, 4, and 7, 6, I think.
9, 4, 7, 6
Yeah.
versus each other?
Yeah.
Yeah, now
Groups versus each other.
You're saying just verse each
Oh,
other.
no, wait, no, that doesn't work. That doesn't work.
Oh, wait.
9485 maybe.
Yeah.
9-4 versus 8-5.
No, what? I can't. 138? No.
1, 3, 9,
I'm just going through a bunch of possibilities.
It's 2 times.
Okay. Like 4 more minutes for this. Does everyone know what we're trying to do? Trying to find 2 sets of coins to weigh against each other, yeah?
Um,
Alright, 1 more minute. Yeah?
I have one for lighter that also works for heavier somehow. I'm never thinking to work otherwise.
Alright, do you want to share with us what you got?
It was from 29485.
9485 is this group, yeah?
Yeah, and then exclude 2 the other group.
Wait, so what's weighing against what?
So
you're
this
okay, that's what it is.
with everything except 2.
So you're weighing the green against the purple, is that what you're saying? Yeah? So notice in...
So for the first group, green is definitely smaller than... Is it smaller?
Yes,
yes.
by a lot.
For this it's equal,
Oh, really?
and then for this it's larger.
Okay, does everyone see this? So if you weigh green versus purple, right? then it has a different result in each case, right? And the measurement doesn't care about anti-clockwise or clockwise. So you're gonna get the two possibilities that corresponds to each of the cases. So here, 2 plus 4 plus 8 plus 7 is 21, and then 9 plus 6 plus 5 plus 1 is also 21. So they're equal, right? So this is a tie. Here, 3 plus 5 is already basically 7 plus 1, but then the 9 and the 8 just kill the 6 and 2. So the green is heavier, yeah? The green is heavier here. And here, but the green here is only like 17, and these two are already 17, so the green is lighter here. Yeah? Okay, so this solves the lighter case because each outcome tells you exactly what this coin is, right? You see? You know this is 2, this is 3, this is 4. Okay? Alright, good. What about the heavier case? So if it's heavier, then we know it's 6, 7, and 8, yeah? 6, 7, 8. And this 6 will be 9. It's like that or the other direction as well, right? And the 7 is and there's the 8. Okay, 9. No.
Yeah, it works exactly the same way.
Okay, so I guess you didn't get as much time for this because it would be natural to just try the other thing and see if it worked. So the green versus purple.
Tie. No, I can't count.
First one it's
So
first one's obviously middle one they're higher and that one is
Yeah.
which one's the tie?
second.
So the middle one gives you 19 versus 19, yeah? So this is a tie. Okay. The left one, the purple's heavier, yeah?
Yeah.
So the purple wins.
Every number there is 2 greater than the other ones.
And here, the green is heavier, yeah? See that? 23 versus like less than 20. So then in this case, you know it's exactly what the coin is at the top. It's either 6, 7, or 8, yeah? Alright. So that there's only one case left, is if they tie. Yeah? Okay. So this is
I don't think you can apply this.
so if they tie, we have so it's 1, 5, or 9, right? That's 2, 4. Or it's it's like this, yeah?
Slight issue. You did the same thing as before, they all tie, so you can't do that.
No, we can't cheat.
Oh, they all tie. So 11,
No where we're like
22 versus 22. Here there's
'Cause each
20
pair adds
versus
up to-
20. Yeah, I guess this is part of like the condition, why those were the ties in the first place, right?
yeah.
So this is kind of related to that. So if you do the same thing as before, it doesn't work, okay? Because they all tie. You don't
Right,
distinguish
if
them.
you do any sort of symmetric formation, they all tie.
Yeah.
Oh no.
Wait, no, at least for one. Oh wait,
Hmm.
no. Oh wait, no. Oh wait, no. Yeah, wait. Because all of the pairs they add up to
No,
9,
that
or
makes
8,
it
or 7,
harder.
11, or 10, or 9. Yeah.
Okay. I might cap this at 9 minutes. Okay.
This is kind of a stupid
So
question.
if you choose any
Chords, like weights are in Agnes version, right?
The what?
The weights of the chords are in Agnes.
Yeah, they're going around in a circle. Yeah. They're in order. Yeah. So that's why there's 2 possibilities. Otherwise, you could get more, right?
Is it possible?
Hmm?
I'm doubting fundamental.
Theorem of total towns.
Yeah.
It's too fundamental to be proven. It's like an axiom.
Yeah.
It's like before definitions were even made.
I guess our focus is right now on finding a configuration which isn't like vertically symmetrical, which like works clockwise and anti-clockwise. Because we can't just pick the vertically symmetrical pairs like we have to do inside. Because
The answer could shock you depending on what you assume to find it.
Why does that construction not? Does it work? I am now doubting if the construction doesn't work.
So you're saying this can't be solved?
oh, it's always so symmetrical.
He's complaining about symmetry. Artificial intelligence. What?
I can tell you, ChatGPT could not solve JA6.
We took a long time to solve it, so it's like kind of not his fault.
It just basically guessed yes, yes, no. That's like, and then the proofs didn't make sense.
Isn't that what we did? We guessed yes, no, and just like.
And the proofs didn't make sense. Yeah.
But then we ended up proving that it could actually be yes for Q.
Then we made the proofs make sense.
What happens if you just tell ChatGPT it's possible under 10 we showed, but is there possibly less?
It's like, oh, of course, you're right. Now let me spit out some more words.
Yes, it is right, but according to the fundamental theorem of cyclic doubly digits.
I tried to pull out some linear algebra to solve part C.
What? It's like, yes, then I'll support this with the fundamental theorem of tournament of towns.
No, it's so fundamental. It's like ChatGPT doesn't know it.
I'll spoil this in 5 minutes, guys.
Wait, so it is possible.
Yeah, so the hint is it's possible, okay?
Oh yes, that's just what I needed.
You've passed that threshold.
Yeah.
So unlock the hint.
So rather than accepting defeat, now I have to fight for victory.
Yeah. And then maybe a hint for Patrick, it doesn't necessarily have to preserve rotations. Well, it doesn't necessarily have to have both directions. Oh, okay, that's maybe a little misleading. But yeah, this is a tricky one, but... Huh? It's tricky and not tricky at the same time.
No.
It's like a trick question. It's like a trick question.
It's game over.
Trick question.
The moment the question is both possible, impossible, and neither possible and impossible at the same time,
Yeah,
is the
trinary
one we'll
logic.
start giving up.
The excluded middle, no longer excluded.
This is one case, by the way.
Huh?
Proof by exhaustion.
Yeah, you can
Yeah,
literally
but
prove it by
like-
exhaustion.
No, we can't.
Wait, can you prove a question by proving like every single case?
That's like you call a case bash.
You know, like NP versus P, they prove like something like the proof has to be more complicated than some particular. Like, they prove something about the complexity of the proof. If it were to exist, it'd have to be at least this complicated.
What was the proof?
Huh?
What was the proof to that?
No, I don't know.
Was it just like we tried? I'm sorry.
Like, if we can't solve it, it mustn't be this simple.
Well, it's a question, so it
And
doesn't
then some like Terrence Tao computing just goes like, oh, actually.
When do we go from normal conversation to Terrence Tao?
Alright, are you guys all giving up at this point?
No.
No,
So
absolutely.
there's 2 more minutes. You could also give up those 2 minutes. I get an extra 2 minutes of explaining.
You don't need that long.
Oh, we actually do it. It's GME.
He's beanbagging.
I want to put it on the floor, but I also want to get a good view.
That is possible.
Just sit in front of the table.
Sebastian's dilemma.
Oh yeah. Wait, my lemma or my dilemma?
Oh.
Why not both?
Let's go.
No. My friend's saying that to me. Wait,
Do they actually say Obama had six?
yeah. My friend was saying to me, like, Obama get dick. Obama get dick.
I don't think it was get it. I think we just have it. Wasn't it like Arabic? Yeah,
that was like 2
wanting
years
a lot of
Obama.
Guys, how do you feel about the Arabic numerals?
Yeah, it's called Hadal Abek, and it's
Yes,
I couldn't
Arabic numerals. Something I've never used Arabic numerals in my life. Definitely.
Isn't that what you're using right now?
No, those are American numerals.
It's not Hindu
Alright, guys. This is like the sound of giving up, I hear.
Hindu Arabic numerals.
Okay, so this is actually pretty crazy because you can actually do this probably a lot of ways. The point is here you don't need to actually find out if it's 1, 5 or 9, okay? In fact, it's actually better if you don't find out it's 1, 5 or 9. Okay?
How does that work?
So basically, there's one kind of idea, like if I just took, so this, let's just say this is clockwise, right? So it's increasing clockwise, yeah. If I just took anything that's going anti-clockwise, yeah, I can take anything. Sebastian, your phone is buzzing. So I can take anything that's going anti-clockwise, okay? So I start 1 there, yeah. I can just go anti-clockwise. And there's always going to be an overlap. Okay? That's crazy, right? So as long as I have some clockwise and some anti-clockwise as the 2 possibilities, I'll always know a coin. Yeah?
Oh no.
Does that make sense?
Okay, yeah.
Okay, so I do need, so Patrick is not wrong, so you do need a clockwise and anti-clockwise, but they don't need to be of the same, like, 5, yeah? Okay? As long as you get a clockwise and an anti-clockwise, you can get it, okay? So here's one way you can do it. So this way of doing it is like a recycling. It recycles you can recycle the first weighing as your second weighing, okay? So basically what you do is you look to the left. So the first weighing excludes the 1, right? You can exclude the 9 and weigh these things against each other. Yeah? Does that make sense?
Oh, wait, that's so simple.
Okay, because what happens there is you reuse the conclusions of the first
Oh.
weighing, right? So you know that like if it's a tie, so this will be 9, right? Or it could be it can't be 4, it can't be 6, it can be a 1, right? Does that make sense? Yeah. So the tied case is literally 1-9 this, right?
Yeah.
And 9-1 this, yeah? And notice here in that case it meets at a 5, yeah? Does that make sense? Yeah?
Yeah.
Okay. Now, okay, they might not be tied, it could be heavier, right? So heavier, it's either 6 or 8, okay? And if it's a 6, then it's a 5-6 clockwise, right? Yeah? If it's the 8, then it's 9-8 clockwise, right? Oh, anti-clockwise, you know what I mean? 9-8. This is reflected, of
Well, it's
course.
just
Yeah.
like you can shift the sort of like axis of symmetry.
Yeah, and so then this one, the 7 agrees, yeah?
Yeah.
Does that make sense? Okay, and if it's heavier, if it's lighter, then it's 2, 3, or 4, right? So then let's say it's like a 4, yeah? If it's the 4, or it's a 2, yeah? So it's either 5, 4, or it's 1, 2, yeah? But 1, 2, 3, the 3s match up, yeah? Does that make sense? So in these cases, you get the 3, the 5, and the 7. Does that make sense? That's crazy, right?
Yeah, that is.
That's
You
pretty
literally,
nice.
like transformed the question.
Yeah. Okay, so the plot thickens, okay?
Possibly it does.
Okay. So
27.
so this case being done in 2, okay? So you can move on to 27, okay? You can move on powers of 3, yeah? It was like it basically in my mind made me think this question was easier than the junior question, okay? Because you don't have to like the answer is probably going to be 3 to the k now, okay? So it's crazy because yeah, like so you don't have to prove that it's the maximum, you know what I mean? If it's 3 to the k, then that's just the answer. Okay, so the next thing I want you guys to find, so I guess to make this possible in a time setting, I'll give you a more controlled question. Okay, so the next thing I want you to find is how do you reduce the general case? So like if n was 3 to the k, right? Can you reduce that to 3 to the k minus 1? So can you actually sorry. Oh, it's not necessarily 3 to the k minus 1, but can you reduce this to a smaller case? That makes sense?
2 to the k turns into 2.
So can you reduce like the general case of 3 to the k or some power of 3 to a smaller power of 3? Okay?
Sometimes when you do the thing where you go like, oh, it might not actually be this,
Yes,
I can't tell if it's like
a spoiler or
like a spoiler or if the first one was a spoiler and you're covering that up. So it just doesn't give me information anymore.
See, that's what happens when you're too smart. Like you've also outsmarted yourself. Like you've used some of your intelligence to outsmart my comment, and then use the rest of your intelligence to outsmart yourself. Yes. If you were smarter again, then you would outsmart yourself again. Levels.
That would be
You need to be odd smart,
Who did you outsmart?
not even smart. Alright guys, I'm not going to give you too much time for this, okay?
odd smart.
So,
It's probably
I'm going to give you like 5 minutes to see how to reduce the case of a power of 3 to a lower power of 3, okay?
n over 3 equals 3 to the power of 4 minus
So
1.
part of the reason I'm not giving you that much time is because it's not that hard to see, but it also takes a while to explain it. So you're gonna have some time.
Is it the same construction? Tell me right now.
It's probably gonna be
Give
like
me
some, we need to,
instant
like,
gratification.
sort of like group up. We need to sort, like, for example, 27 into like 9 groups of 3.
Split it into 3
No.
groups each.
Setting
Ah, instant gratification. It's not
So you
instant.
split it into like n
No.
over 3.
Instant gratification monkey.
Split it into
one works 27.
Split it into 3 equal groups
Right.
and wait while they get to each other.
Right, Michael?
To change instant noodles to 2-minute noodles, and then to 5-minute noodles.
10-minute noodles.
What was like instant noodles? It's
Half
like
an hour noodles.
the moment the noodles touch the water, you take it out. It's just like done.
Genuinely instant noodles.
You take it out of the box. You don't do anything to it, and it just turns into.
All right,
noodles.
4 more minutes, guys.
You
How do you
open the
reduce-
box and it's just noodles.
How do you reduce?
The same construction, surely, right? Give me my gratification.
Then we would like expand the higher level.
What is the meaning of house?
How does it? I think some of you already sort of came up with the idea. Maybe you've already rejected the idea.
What is the meaning of life? What is the meaning of death? What is the meaning of our existence?
Hey, you should not contemplate that question until you figure out how to reduce the power of 3.
I'm gonna tell you what to think.
The
And if you
enemy
don't
of my enemy is my friend.
You want a meaning to life, but you can't find the coin.
Baron Munchausen is screaming at you for taking too long.
Baron's like, hurry up and finish using the waves, because I need to weigh myself now.
The Baron doesn't realize like his claim doesn't make sense, and you're just trying to make it work. He just said K as a universal.
Yeah, I could do it eventually. After a lot of ways, I could do it.
Yeah.
And then you're like, well, in K ways, with K ways, you could do it in 3 to the K of that.
Oh.
Is that an M dash?
Are you asking AI?
No.
Just looking at the theory of everything.
Can you focus? Put away your brain rot.
The negative side looks like an M dash to me.
We have 1 minute.
Yeah, I'm not
done.
gonna be able to solve the question in 1 minute, so what's the point?
Are you sure about that?
Wait, so wait, let me calculate.
I feel like if the illusion is
What about 7?
Sometimes, yeah, like when you're on a roll, the time slows down.
And when you're not, it's like... Sick.
Okay, maybe I'll put a diagram on the screen just to.
How I reduce this case? What do you mean I reduce though?
What do you really mean by reduce?
Like you can use one
Because
move
there's
to
like
turn
a
into
real
1 to 9.
meaning to everything.
Like maybe you can do like
Go on to this thing.
I feel like this is supposed to help, but it's like not.
What an amazing diagram!
The what best diagram of the year?
Alright, fine. I'll explain it to you, okay?
He's
Okay.
slay guys.
Okay. So what you can do, okay, is I literally heard someone say this, okay? You can group them into 9 groups. Okay? So for example,
What?
you can do 1, 10,
Baron Munchausen.
19.
oh my gosh.
That's one group, okay?
Why isn't that dream crashing?
Okay. Oh,
He's
this is
trashing
like
it.
basically the diagonal entry. Right.
He's crushing.
Oh,
Look at
that's
it,
why
two.
it's 27.
Actually,
11,
27 from
20. Or you could have like
the color coding.
3, 12, 21. Have I made my point with this?
Yeah.
So you get 9 groups. The 9 groups are characterized by their remainders
Yeah.
when you
When
divide by
divided
9.
3. Oh, 9. So mod
So literally it's whatever they are mod 9, right?
Oh.
Okay, so you have like basically so you basically have 1 mod 9, 2 mod 9, 3 mod 9, 4 mod 9, 5 mod 9, 6 mod 9, 7 mod 9, 8 mod 9, 9 mod 9.
Oh!
This
Okay.
looks way too
And
familiar.
then you can take that and
Wow,
you can do it
wow,
We meet again.
Wow.
Yeah.
Wow.
Okay, so you gotta be careful, right? So like obviously you can say
Wait,
can-
there's no way.
we can do the
Wow.
we can do this like the 9 case in 2 weighings, right? Okay. But you can't just say it and just leave it. You have to like kind of see if it actually can be done, okay? So these are not actually just 9. The weight of these coins are not 9, yeah? The weight of these coins,
It's like
R
constant plus
X
9,
plus 9x plus 9.
which is
what are the actual weights, right?
27
9k
So
plus
so in
1.
this case it's like 27 plus 18
50.
plus 9, right? And this other case is like it's 1 plus 10 plus 19, right? Okay. Does that make sense?
Why does this work?
So these weighings, you have to be careful. Like when you solve it the same way you solve the 9 case, right? You got to check that the weighings actually sort of make sense. Okay. So what is it that needs to make sense? Okay, I wrote these backwards, so that's probably annoying. So this is 9, 18, 27, right?
It does make sense though, because it's okay. So you can express like the total sum is like what 27 plus like 3 of the number indicated.
Yeah, so this
And
is
so
like
because you
0
added
plus
27 to
9.
everything, it doesn't change any
This
of the
is like
results,
9
'cause
plus
they're all
9.
like
This is 18 plus 9, right?
Oh.
all of the range we
This
did,
is
they were,
0
they had
plus
like
1.
the same amount of numbers.
Oh,
So
I
the
get it.
constant doesn't matter, and then the
Uh,
multiplication is just like multiplying every number by 3.
Oh, that makes
it doesn't
sense.
matter as well.
Plus 9, and this is
1 plus 18.
Yeah.
yeah, 1 plus 18, yeah?
Um,
So basically, can you see that like every group has the same 1 plus 9 plus 8?
0 plus 9
0
plus
plus
18.
9, right?
Oh, I did this one backwards. Yeah, every group has the same 0 plus 9 plus 18, right?
Exactly.
Okay.
And so you just look for 3 times everything, but that you can divide by 3 because it's relative. thing.
Yeah, so you gotta be careful, okay? So notice in the weighings that we use, we always weigh 4 against 4, right?
Yeah.
So if we're weighing 4 against 4, then the common weights always cancel, right? So the plus 18 plus 9 plus 0 don't actually matter at all, right? So then what you get is just 3 times 1, 3 times 2, up to 3 times 9, right?
Yeah.
But having just that's like making different units of measurement, right? You can have 3 kilos instead of 1 kilo, right?
That's not a good example.
What do you mean? Well, if you measured it in 3 kilograms, it'd still be 1, 2, 3 to 9.
Put 3 kilograms to new kilogram.
Yeah. So you're basically scaling everything by 3. It doesn't change the outcome,
Yeah.
right?
You can like.
It's kind of just like making the scale.
Also, like when we compare
Sensitive.
inches and centimeters.
Changing scale sensitivity.
1 inch is now defined
It's literally
as
called
1
scaling.
centimeter.
Sorry guys, I am a dad after all. All right, whatever. So, basically, do you guys see that?
Yeah.
So then you can use the same 2 weighings that you had before to figure out which one of these groups it is. Does that make sense?
Yeah.
Yeah? Okay.
I know this always problem.
So can you see what this does? This reduces 3 to the k to 3 to the k minus 2. Yeah?
Yeah.
Because it takes 2 moves and it brings the power, divides by 9, right? You see?
Can you do
Okay.
it again?
And then within each group now you have like 2, 11, 20. So I guess within each group, you kind of reduce to the smaller problem, yeah? Okay, so assuming that we've got this and this is all true, yeah? Okay. What have we achieved logically? What have we achieved logically?
Induction. N equals 3 to the k in some cases, but not in others.
Okay, which cases?
When it's 9 to the when k is even.
Yeah. So you can basically divide by 9 as much as you want, right?
Yeah.
And when it's even, when you divide by 9, you're gonna end up with 9, right? And 9, we know how to do that, right? Does that make sense?
But then when k is odd, then you get 3.
But when k is odd, you get 27, okay? So 3 we know you can't do in one move, right?
Yeah.
So we got to say we can show, can we do 27 in 3 moves? Does that make sense?
Oh yeah.
Okay. So basically, we solved if 27 is solved. Does that make sense?
Yeah.
So it suffices to solve it for 27.
So prove that it can be done in 3 or can't be done in 3.
What if n is like not like a power of 3?
We don't care because.
Oh no! Like if we can show it works for power of 3, then we're done.
Yeah.
Because power of 3 is the maximum.
Oh, okay.
Yeah. So if it doesn't work, that's when we have to worry about other things. Yeah.
I should have used
So
that in
if
mind first.
so if it works for 27, okay, then it works. So if you can do 27 in 3, then 3 to the k is the answer. Okay. That makes sense?
But how do we prove that it can't be 3 to the power of k plus 1?
Because it divides. The
impossible.
branches go into 3 groups every time. So that divides by 3 every time. And you have to end up with all 2s. So 3 to the k, when you divide it k times, it'll end up as all 2s. But anything more, it'll be like a 3 somewhere.
Also, what do we mean by like all 2s?
Okay.
Alright, so you have 18.
Yeah.
So this is going to go to 6, 6, 6. And then this is 2, 2, 2. So each of these, like, trisecting is like a weighing.
Like, what do we mean by 2? Should it be like 1? Like, there's like 1 possibility after 2.
No, it's 1 possibility for this coin, but these could be like 2 here or 2 on this side. So that's 2 possibilities. It could rotate one way or the other way. You don't know what the other coins are. Okay, and obviously if I had more than 18 here, one of these would be 3, and 3 is too many. You can't tell. Alright, I'm not going to waste any more time explaining that, okay?
Oh yeah, that makes sense. Solved if
We had a delay of like about 2 hours.
Solved if we
Okay.
can kill the 27-year-old.
Yeah, what? Huh?
The
Guys.
20-year-old.
Guys, we're really running out of time, so I'm gonna give you sort of 2 minutes and then a hint.
The hardest question in the world has almost been solved.
Yeah, we got 8 minutes to solve the hardest question in the world.
Oh no! Oh no!
I feel like we need to talk about this hardest question in the world. Being referred to as that.
I am
Well,
a
it's the hardest high school question in the world, okay?
I am a Q6.
And it doesn't require any knowledge. Isn't that crazy?
I'm a Q7.
So the difficulty comes purely from problem solving. Don't talk to me about Turbo the Snail.
What?
Turbo the Snail.
N equals 3 is the answer.
What's so
Like,
special about Turbo?
I don't mind if it's like a hard question that everyone can't solve, but it has to be like easy for some people and hard for other people. In like a very predictable way. Alright, let's not talk about that. Okay, so I guess the hint is basically just to check whether this crossed your mind or not, okay? Because I think the hint will be relevant to everyone for which this crossed your mind. Counterclockwise.
If it goes like say, if it sounds like clockwise, you have to consider what the case was counterclockwise. I know what I'm saying.
Okay, the time it take for me to scroll back to this.
Is there a way to generate this down to the 9 case so that we don't have to actually like do this?
The zoom is an apple.
We divided into 3 groups of 9.
I mean, it's a little bit of a hint that I'm not giving you that much time to do it, right?
We divided into 9 groups of 9. 9 times 9
What do you mean
equals
9 groups of
27.
9?
Like, presume it's 1. It's the same trick that you said. Take the whole list of events.
Wait, can you do it in 1.5 ways?
Alright, okay, so alright, I'm gonna give you the hint, okay? So for the 27 case, right? Okay. You can use the trick that we just did to reduce it to the 3 case, right?
But 3 doesn't work for 1.
Okay, but 3 doesn't work for 1, okay? That's the hint. That's the hint. You have 3 minutes to figure out what that hint means.
3.
It's like a nightmare.
Semi Bastion used to do whatever.
Did you call him 3 Bastion?
Semi Bastion.
That would be needed right now. 3 Bastion. We don't need 4 Bastion.
Nether Bastion.
Okay, so if you use that trick, it reduces 27 to 3, right?
Yeah.
And 3 can't be solved in 1. Okay?
No, it has to be solved in 1.
That you cannot do solve the 3. We can
Wordle in 3.
Okay.
It's currently 8:23.
Yeah, you have 2 minutes. So I'm making I make a I made a statement, right?
yes.
You can reduce this to the case of 3, and 3 can't be made in 1. I just said that statement. Okay.
Yes.
Does that help?
Is
You
he
never said-
very
He
trusting?
never said how
27
many
can't be
groups
made
you
in
need.
3.
Yeah.
Reduce it to
So it can be made in.
It could be made in 4, because 3 can be made in 2. So you multiply it by.
Okay. The answer is sort of also right in front of you as well. Just have a look at the
The
diagram.
answer is always in front of us.
Yeah.
It's just never visible.
Have you seen those experiments where people have like the buildings in the background that they don't even notice there are buildings there? They're just so focused on, and then they don't see the gorilla come out of it.
Oh yeah, I see that one.
Yeah.
And it's like we unfocused.
95%.
Everything is.
95% of the time I just like don't care about the actual task. Because like, oh, focus on the number of times they throw balls at each other. And it's like, I'm not gonna do that.
Okay, so you got 1 more minute. Is the statement that I said actually true, okay?
Yes.
Yeah.
So you can reduce the 27 to the 3 case, but the
Okay,
3
the first
case,
part is wrong.
but the 3 case doesn't work in 1.
And we showed that that is always the case.
Proof by Dr. Sun, it's not true. And it's false by the first statement.
So that means that 27 can't be done in 3.
How do you know that?
Because that's what Annie said.
Because clearly by fundamental theorem,
Less than a minute.
according to Sebastian's phone, it's now time.
It's 8:25.
Alright, it's 25. Alright, so what is the 3 case, yeah?
Yes.
It's literally 1.
I mean, this one I think
2,
it is. It's 1, 2,
and
3.
3.
Our 3 cases 1, 10, 19.
Yeah, you don't have 1, 2, 3. You have 2, 11, 20, okay? So there's something wrong with that, you understand?
I thought of this like 10 minutes ago.
Yeah, so this should have all crossed everyone's mind, okay?
Yeah.
So it doesn't quite reduce to the 3 case, okay? That's for 1, because 2 of them don't add to the 3rd, okay? And part of the reason it doesn't reduce to the 3 case is because, remember how we did the weighings? Like we cancelled out the extra stuff because we weighed the same stuff with each other, right?
Yeah, but like with
So that might not happen with 3, okay?
Well, you have to weigh like the same, like
Okay.
1 against 1.
So another thing I want to tell you is just abstractly, okay, it doesn't exactly reduce to the 3 case, right? Because it reduces, like, even if it did reduce to the 3 case, it would reduce sort of to the 3 case surrounded by a whole bunch of other coins, right?
Yeah.
Does that make sense?
Yeah.
So you have 3 coins that you need to determine with all these helper NPC coins that, like, just like a ton of, you have another 20, you have another 24 coins to help you with the 3 coins. You understand?
Wait, the 3 coins here are 9.
Alright, we're really running out of time here. So I want you to think about how you might do this in 2 minutes. Okay, I got 2 minutes.
Let me think about it.
Wait, so we're condensing the 27 case down to the 3 case.
Yeah, but it's not exactly the 3 case, so you have a hope, okay? Because if it was exactly the 3 case, you're screwed, right?
Yeah.
But the exact 3 cases, 2 of them add up to the 3rd one, but your thing doesn't even have that property, and you have all these other coins that can help you, right? Okay. So think about if it was like 2, 11, and 20, how you could separate the 3 of them, yeah?
Just have one of the
You only have one weighing.
coins as like an anchor.
You're not far off.
What if we do it the same as the way we did it with like a 9? We like divide it into 2 different halves.
That doesn't work. There's a reason it's like not the same as the 9 or 3 case.
So the original 3 case doesn't work because 1 plus 2 equals 3 ties, right? But the 3, like, no matter how you do it, will always be bigger than the other
Can you
ones.
put the same coin twice?
I'll put the same coin
One
twice.
of the physical
Okay.
Alright, 1 more minute.
Because if you could, what if you halved each of the other coins?
Shut up.
Oh my!
Where are we finding two?
How far are we off track?
If you just have every
Get a
single coin,
sword.
that
Oh,
would be
then we get like multiple of 2. It's like 54.
Okay, I'll give you a little bit of a hint. I mean, you probably want to use more than
Yeah.
just the
You
3
use
coins.
Outside numbers.
yeah, use like a fixed number to help you check.
We might have to go over time a little bit, but only a little bit.
Is our goal to like separate like the 3 numbers in the triangle?
You want it, so you end up with 2, 11, and 20, but you don't know which one's which, right?
Wait.
Yes, they are weights.
No, thank
Huh? Sorry. I'm just distracting at this point.
He's just a dad.
Ah.
From the 9 reduction, you already know like which I guess
Yeah, you know it's 2. Yeah, this one is like, you know it's 2, 11, 20, yeah? You just don't know which one's
Oh,
which.
you can duplicate them.
Sort of, yeah.
Oh! Ah, okay, I see.
We have the 3
I
case 90.
see.
Wait, we have the 3
I
case
see.
like 9 10.
Okay, so check this out, okay? What you can do is, notice, in this case, you have 2 plus 20 is 22, right?
Yeah.
Double.
Okay? But 12 plus 10 is 22, right? So if you weigh 12, 10 versus the red ones, so 1 green and blue versus the 2 red ones, right? You see?
Exactly.
Then the tying case tells you this is 11, right?
Yeah.
Does that make sense? 21 and 19 is way bigger than all the other 2 things, right?
Oh.
So in the bigger case, it's 20, yeah? And 1 and 3 are tiny as heck, right? Does that make sense?
Yeah.
Alright, does this solve the problem?
No.
There's
Yes.
1 minute left.
But it does solve the problem.
Okay, there's no minutes
It
left.
solves the problem.
Does
'Cause
it solve the problem?
we know which one's which. We know which one's which.
No, it doesn't.
So we know at
because
least what we know at least 1 coin.
What happens if it's like 9?
What
No.
do you mean it's at least 9?
What happens if?
What happens if it's
What
9?
What happens if it gets too big?
Wait, question.
Yeah.
How do you know that like the 3 numbers that you're picking are indeed
27.
2, 11, and 20?
Yeah, exactly. Okay, so you're basically all on the same topic now, okay? So this works, okay? So we don't have time to check every case, but I'll tell you that this works for all the case, like 2, 11, 20 it works, yeah?
Yeah.
3, 12, 21 works. So it works for every case except for when it's 27,
18 and
9, and 18.
Oh for 1.
And it doesn't work for 1. What's the other ones? 10.
10.
Oh, that's this is the green one. It's already colored, right? It's already
So you
colored.
want to add them all together and if they equal.
See, why does it? So that doesn't work for those two cases, yeah?
So you need to add them all together.
How do we solve that?
Add them all together. If they're not equal, then you can use the trick. But if they're
Okay,
equal-
I'll give you like 3 minutes and then we'll end the lesson. Okay, and this is basically the order we solved the problem yesterday. Okay, this is literally live solve. You want to see the live solve? It's recorded on video as well. Okay. How do you do it? So 3 minutes. How do we solve this last case? So 27-1 is not covered. Okay. You understand?
That's so clever.
It is, right?
Wait,
This actually makes
It's
you
real
want to
problem
cry.
solving.
You want to add them.
Right.
You want to start by adding them together. Like adding the triangle together.
This is why we go to war-torn country to get math problems. Okay? Somehow I managed to make it hard without assuming any knowledge.
Next, we look at South Sudan.
And we come back and it's like, oh, we didn't get anything.
We're more focused on
South Sudan senior contest.
SSC.
It's like all of those countries just get zeros across the board in the IMO.
It's like, yeah, I don't want to say.
When's the last time they registered?
Alright, 1 more minute. This is actually not that easy, but it's actually not, like, it doesn't take long, it's just a hard realization. Like, actually, the thing that makes this problem hard is the realizations. They don't actually take time, you understand?
Yeah.
Like, any realization is like a 1 line to write down, you know?
And then it's like a 40-minute screaming session.
Sponsored by the Cuban cartel.
Alright, last
I
minute.
know.
2 minutes, realize what happened.
This
So you understand, so the point is we know what case we're in, right?
Yeah.
So we have 9 possible cases, and we actually can solve all but 2 of them, okay? So what do we can actually come up, so we can actually in principle come up with a different solution for the other 2 cases, right?
Yeah.
So what do we do? So how do we take care of those 2 cases, right? That's the question. So we've taken care of all the other cases, yeah? And this is actually like a quite a difficult question, but not a long question.
I need to make sure I know.
There's Malak.
Yeah. Okay. Yeah.
Wait, what if you just do the thing where you just consider the ones like the left?
Wait, without
Wait,
spoiling, did you
yes.
actually instantly think of it? I'm talking to Andy.
Yes.
Oh, it's pretty crazy.
Wait. Hang on. Why can't you like? I was like, what's the most like memorable thing it was? Oh, case 9 tying. Right.
Yeah, so one day I wanna take you to Moscow.
Oh.
Go to the summer conference.
Wait, why can't you like do this thing we did for 3?
So
Huh?
Why can't we do the thing we did this for 3? It's like we like weigh 2 of them against 1, and we do it again, and if they like work together, then it must be like 27. Then we identify 1 coin.
I don't understand what you're saying. So with 3 coins?
So like we pretend like we choose these 3 numbers. We pretend that like it's like a 3 case.
Yeah.
So it's like
But that'll take 2 moves. We only want to do in 1 move.
oh.
Yeah.
What if instead of like the 27, 18, and 19, just consider the coin on the left and do the same thing? Just like,
Consider the coin on the left.
I wouldn't even move it. Wait, that would really work.
Actually that's pretty clever. Hold on, wait. He's saying that's pretty clever, right?
You do exactly the same solution, but the one next to it. That was my solution.
2 away from it because they could be.
Wait, but how would you know which one's which? So wait, hold on. So
Okay,
you're
so
saying if it's 27, and you know it's like multiples of 9, then you move.
no, but the orange.
How do you know which way to move? Because if you move the wrong way, you get the other case you can't solve.
Just move 2 then.
Yeah, move 2.
2 in some direction.
Yeah, then you automatically get a solution you can solve.
Okay. But then wait. But then how do you know it's which mod it is?
Oh yeah, right. Wait,
Do we know it
does
in
that
this
even matter
case?
that much though? You just
Huh?
need to figure out which
Do
one
we
of
know
those
it
is
in this
correct.
case?
Well, we know. Oh, actually, wait. Do we? Yeah, actually, if we do know it's 0
Just
mod
figure out which
9.
one of the
If you move it.
is
Oh yeah, actually, if you move it, you can move it 1, and you know it's 8 mod 9, right? And then you can solve that, and you can figure out. Wait, which one do you know is which?
Wait, so if it works, you just shift it
Oh,
one.
actually, that kind of works.
Yeah,
Actually,
that was my solution.
is it?
Yeah. If you do like that thing where you like add like the two numbers.
Okay, that's not the solution we came up with. Okay, but that's actually pretty clever. You see what they're saying to do? So if you end up in the 27, 18, 9 case, actually you don't know what direction to vote. So you move 2, but you don't know what mod it is. But you move 2, you could end up at 2, or you could end up at 7.
Either way, it's a safe spot.
So, but you know which one it is, but you don't know if it's 2 or 7. Okay, do you want me to spoil the answer?
Yeah.
Huh?
So.
Okay, so the reason why this is difficult is because it requires some memory recall, okay? So do you remember when we were doing the 9 case, what it all ended up as, okay? So you remember how like it tied and then it was greater and lighter? And it was 159, right?
Yeah.
And then the 159 ended up as 375. Do you remember that?
Yeah.
And then the other ones just got split into whatever they were. So 2, 3, 4 was just 2, 3, and 4.
Yeah.
Right? So if you remember that case, right? This is a product of that case, right? The 3 that you end up with is like the output of doing that process, right? So if you paid careful attention, you'll see that process never produced 9 mod 9 and never produced 1 mod 9. You remember?
Yeah.
So it was 2, 3, 4, right? And then it just produced 2, 3, 4, yeah? As the coin that you discovered, right?
Yeah.
And then it was like 7, 6, 8. And then it just split up into these 3, right?
Yeah.
But then when we did 159, remember, we ended up with like 3, I don't know which one was 3, 7, and one of them was 5, remember?
Yeah.
We never ended up with 1 and 9. So those could never be produced.
Wait, so that means we didn't care about them.
Yeah, they could never come out.
Oh.
Wait, what?
You know what I'm talking about?
We could never.
So when we're doing the 9 coin case, right? Yeah?
Yeah.
You know how like our method produces a coin that we know exactly what that coin is, right?
Oh.
So if we know the coin weighs 5, then we end up with the 5 mod 9 coins here. Does that make sense? Yeah? If we know the coin weighs 4, we end up with the 4 mod 9 coins here, right?
Yeah.
So for us to end up with the purple coins, we have to get 9 mod 9 as our answer for that 9 case, right?
Yeah.
But we never did. We never got 1 or 9 as the answer. Remember when it was 1 or 9, they just kind of twisted and met at 3 and 7 and then 5. Do you remember that?
Oh. So it can never even show up.
It can never show up.
So regardless, it doesn't matter. I mean, so
Yeah. That's crazy, right?
I love fake solving. Which means that those problems will never appear.
Yeah, so the cases that we did it actually solve it because 27 and 1 can never appear as the things the groups of 3. Yeah.
very only exact.
Yeah. I guess we also have a video of us coming up with this in real time if you want to see it. It's much slower than this, okay? It's just like
All of the 3.
I mean, if you're curious, I can send it to you. Just DM me on Discord. It definitely makes us look a lot dumber than this does.
But yeah, but like you basically had to like give it away. So
Yeah.
who knows how long we would have been sitting here if not for your hints.
Yeah, well, that video tells you how long we were sitting there.
Was that for the whole lesson or was that just for like a little bit? Wait, if we know
Well, it was approximately like 3 hours worth of thinking. But like there was a lot of sort of time wasted as well.
if we know this, does that mean that we can do it in one way?
Yeah, you can do it in one weighing. So you don't have to worry about the cases where it doesn't work because they never appear. That's the point.
So we write our answer down as 3 to the k.
Any
Population was correct.
if n is greater than or equal to 2, 3 to the k, otherwise 2.
Yeah.
Alright guys, Max, did you understand that?